In this project, I will be building a small pet store database connected to a RESTful API. For my tech stack, I'm using Java, Spring, and Spring Boot to define and build my database entities, map the entity relationships, and to define and map the REST endpoints to data service operations. The project database is a locally hosted instance of MySQL, and I'll be using Maven to build the project and manage the project dependencies. Maven projects organize their dependencies and their configurations using what is called the project object model, which is stored in the pom.xml file that Maven places in the root project path. You can look up the appropriate values for the POM file using the Maven repository, or you can look them up with a tool such as the Spring Initializer, which is what I've done on this project. The nice thing about the Spring Initializer is it injects all of the dependencies into the POM file for you. So at the end, all you need to do is copy the POM that's been created into your project. For my project, I'm using Lombok, which will let me convert annotations into boilerplate code, so such as getters and setters. The Spring Data JPA is going to allow me to map Java class files as database entities and class file instance variables as entity relationships. The web dependency brings the Spring Model View Controller, which is what I'll be using to map and build REST endpoints to data service operations. And then finally, the MySQL driver bridges the gap between Java and MySQL. When Maven builds the project itself, it's going to expect all of your class files and your packages to be located under source main Java. It has source main resources for all of your further configuration files, and that's where my application.yaml file is located. This is where I define the Spring configuration file for the database URL and authentication methods. The database schema for this specific project is going to have 3 tables: pet stores, employees, and customers. Pet stores can have, each pet store can be associated to many different employees. Each employee is associated through the pet store ID foreign key to one singular pet store. And then pet stores can be associated to many customers, and customers can be associated to many pet stores with the pivot table pet store customer. Now, JPA will allow us to use annotations to build these tables with Java class files. And then the further annotations will let us use Java class file instance variables to define the relationships. The first step is to actually start the component scan to look for those annotations, and that's done in our main method class. So in my main method class, pet store application.java, I've added the annotation Spring Boot application. And then I call Spring application.run and I pass it this main class. This is going to start the Spring's auto configuration feature, and it's going to most importantly start the component scan. Then I go about building my classes in my pet store entity package. This is where I'm housing all of the classes that will be entities in the database. If I look at my customer class, I have the @entity annotation. This tells Spring that this is going to be a database table. The @data will fill in all of my getters and setters. You'll notice they're not explicitly in this class file, but Lombok managed them for us because of that notation. Then each instance variable in this class will be a column in this table. I use the @id and @generative value annotation to tell Spring that the customer ID value will be a primary key and that the SQL server is going to manage that value. I've also added a column constraint of unique to the email value. The way JPA handles entity relationships is through recursive class instance variables. So customers can be related to many pet stores, and pet stores can be related to many customers. So a customer will have a collection of pet stores, and a pet store will have a collection of customers. We use the @many-to-many annotation to tell Spring that this instance variable is a relationship. And then we define the name of the pivot table, pet store customer. And JPA uses the term join column and inverse join column to describe the two table names the two table columns that we'll be using to establish the relationship, the foreign keys, pet store ID and customer ID. The one-to-many relationship works the same way. A pet store can be related to multiple different employees. So a pet store has a collection of employees. Employees have a relationship with a single pet store. So the many-to-one relationship with employees has a single pet store variable. With all the annotations in place, when we start the application, Spring's component scan will build these tables and build the relationships between the tables. The best way to see that is to use a database client such as dbeaver. So I can pull up dbeaver connected to the pet store database. I'll drop all the tables just to start so we can make sure that we're dealing with a clean slate. And then when I start the Spring application, we should see the tables be created. Spring starting up. You can see Spring started the application in 3.8 seconds. It's still running. You can see that the Hibernate module of JPA dropped all the tables, created the tables, and then created the constraints. We did have a little race condition where it was trying to alter pet store customer before it existed, but it gracefully recovered, and you can see the tables were created. If I go back to my database client, I can refresh. And not only are all the tables there, but if I look at the entity relationship, you can see that pet store is related to customer through the pet store customer pivot table, and pet stores are related to employees.